Hi everyone, Noah here. I'm a blockchain developer with Project Hydro, which is the blockchain division of the Hydrogen platform. Today I'm going to be walking you through server-side Raindrop. Server-side Raindrop is a product that we created to secure access to and protect large shared resources, such as APIs and databases. Before we jump into the specifics, let's talk a little bit about authenticating with the API and interacting with it programmatically. When you log into your account at hydrogenplatform.com, you should see a splash page that looks something like this. Under the blockchain entry here, you should have a username and a key. These values are your credentials that you'll use to authenticate yourself to the Hydro API. For the sake of the video, of course, mine are obscured. Now, instead of interacting directly with the API, I'm actually going to be using an SDK, a software developer kit. We've developed JavaScript and Python SDKs to facilitate your use of the Hydro API. They're not strictly required, but they abstract away from a lot of the trivialities and let you really focus on the core functionality. So let's get that JavaScript SDK up and running. I'm going to switch over to a terminal window here, and you can see that I've already installed the SDK here with npm. So let's boot up a node session and initialize some variables. I'm going to switch over to some boilerplate code that I have right here. This first line simply loads our Hydro API credentials from the website into our current process. For those of you following along at home, I have this .env file here that I won't show for the sake of privacy on the video, but in reality it just looks like this with my client ID and client secret from the website entered into these appropriate fields. So in the terminal, we can just load that in. And next, we need to load the SDK as a package. We'll just do that right here. And since that was successful, we're ready to go. This server Raindrop partner object is just a wrapper for a lot of API calls that we're going to be making, and it's initialized with 3 variables: the client ID and the client secret that we've discussed, and this environment variable, which is currently set to sandbox. Sandbox is the environment in which you're going to want to test all of your functionality. It doesn't use real tokens. It makes it a lot easier for development. Basically, before you roll things out to end users, you want to be in sandbox. Great, it looks like that worked. So now we're ready to talk about the specifics of server-side Raindrop. If you imagine a shared resource over here, like an API, and an end user over here, in order to access the resource, the end user needs to be added to a whitelist. To do so, the end user needs to give the authenticating resource its Ethereum address. So to get that Ethereum address, we'll go over to a MetaMask account here, and we'll copy this public address. Next, acting as the shared resource administrator, we're going to call this whitelist function with the Ethereum address of the end user as the argument. So we're going to copy this code, go over to our REPL here, and make that call to the API. So the result is going to be in this whitelist result variable, and it looks like our call was successful. Great, so we got a Hydro address ID and a transaction hash from this call. The Hydro address ID is what we're going to be using later to identify this user. The transaction hash is the identifier of the transaction that whitelisted this particular address. So let's actually check that out right now. If we go over to a block explorer and we search that transaction hash, we see that it's still being mined, and it basically called this whitelist address function of the smart contract in question. If we refresh here, it's still being mined, so we'll just let it be for a second. The next step is request challenge. So once this user has been whitelisted and they want to authenticate themselves, we'll need a challenge for them. So in order to do that, this request challenge function takes the parameter of the Hydro address ID that was returned earlier. And while we're waiting, let's check if this transaction has finished. Great, it looks like it did, so we're ready to move on. If we send this request challenge to the Hydro API, it will return us 4 variables: an amount, a challenge, a partner ID, and another transaction hash. This amount is the number of Hydro tokens that the authenticating end user is going to need to send to the smart contract in order to prove who they are. This challenge is a secret variable that does the same thing, but with a different focus in mind. This partner ID is an identifier of the shared resource that we're authenticating with. So these variables need to be sent by the end user to a smart contract. And there's many ways to do this, but the one we're going to use in this example is through MyCrypto, a popular web wallet. So we're going to load that up right here. and we're going to click on the Contracts tab. You'll see that we need an address and an ABI JSON interface. So to get those, we're going to switch over to the Hydro API documentation. And as a side note, if anything I've said is confusing or if you have further questions, in all likelihood the answer is probably in these documentation. So if we click down to the Raindrop server-side smart contract section, we'll see that since we're in the sandbox environment, this is the address we're interested in. And this is the link to the ABI, which is here, that we'll need to paste here. And if we click Access, then we're able to interface with this contract. And we're interested in calling the Authenticate function. And as you can see, these three variables required by this function are exactly those that were returned by the API. So if we switch back over to the API results, we copy this amount here and put it here. We copy this challenge here and put it here. And we put the partner ID of 1 here. Then we're ready to send this authenticating transaction for the end user. So we're going to use MetaMask again, and we're going to confirm that all of these variables are correct. Make sure that everything looks right here. No problems. We're going to click Send. And finally, this MetaMask transaction is going to pop up. It looks fine, so we're going to click Confirm. And that means that our transaction has been broadcast, and we're waiting for it to be mined. So while we're waiting, if we go back over to our boilerplate code, we could check as the authenticating resource whether or not this user has been properly authenticated. So if we copy their Hydro address ID again, and we put that right there and make this call, then we see that the call was successful and the results of the authentication is true. The Authenticate transaction we just sent went through. And it looks like it did. So we just went through the entire process of server-side Raindrop. An end user gave their Ethereum address to the authenticating resource, which called whitelist. After that successful whitelist, the authenticating resource requested a challenge on behalf of that user. Those challenge variables were relayed to the end user, who sent a transaction to the Hydro smart contract on the blockchain. After doing so successfully, the authenticating resource was able to call the authenticate variable function in the Hydro API and verify that that end user had correctly authenticated. So at this point, the end user is free to move on to the next step of the authentication process or gain access to the resource outright. I hope this tutorial was helpful. I'll be sure to throw some links and notes down in the comments below. Thanks for watching.